Okay, so example 4, so the SUVAT is, or the constant acceleration questions are properly starting now. So initial velocity 3I, take away j, so for me, 3 negative 1, feel free to use the I and j if you feel more comfortable with that. Constant acceleration, but we don't know what that is. After 5 seconds, so time is going to be 5 for the period that we're interested in. Velocity then 1.5I to 1.52. Look out for them swapping the order. So for example, that initial velocity that is written as, if it was the other way around and the j was positive and the I was negative, they could easily swap that order. So you've just got to make sure you're careful that it is in the right order, I then j. Find its displacement and distance. So S is going to be the displacement, we'll then find the distance. That's 3 that we've got, 1 that we need, so we can use our equations without A. So that is going to be not very commonly used. Half E plus VT, effectively the equation of a trapezium. I'm going to be a little bit careful how I write the inside of the bracket there. I think the vectors in particular can make it easier, but can also be a little bit confusing. So S is what we're looking for, so half, I'm going to use a square bracket, and then a curve bracket for my first vector, second curve bracket for my second vector. Could always put the times by this front as well, so that's 5, and then U is 3, negative 1, and 1.52. And then I can just shove that in my calculator, one line at a time. So the first one is going 0.5 times brackets 3 plus 1.5 times 5, so 11.25. And that's all I'm doing. I'm just going to go back in and just change those middle two numbers in my calculator to minus 1 plus 2. Efficient, not lazy. Okay, so that is the displacement. Okay. And then for the distance, hopefully no surprise that we're going to use Pythagoras. Because I'm only after a distance, I'm not after an angle, I'm not going to bother with a diagram here. Okay. And I think that is all there is to this example.